All right, so I have a question for you. Doesn't require a great knowledge of transformers. All you need to know is the transformer is a coil of wire wrapped around here, and then there's a coil of wire somewhere else. So here's a battery. There's a switch that's open. When I close it, that battery will be connected with a coil of wire and a resistor in series in one loop. Because of this iron yoke here, the magnetic flux that goes through this coil of wire also goes through that coil. So if there's any magnetic field there, this coil of wire will have it through it. This is just a coil of wire that has an ammeter connected. So the ammeter is measuring the current in the coil of wire. So here's my question for you. The primary coil of this transformer, connected to a battery, resistor, and a switch. When the switch is thrown, the instant the switch is thrown, what does the ammeter show? Forgot to tell you you're running out of time. Main answer tends to be the right one. Yeah, when you close the switch, the current suddenly goes up. The magnetic field changes really quickly to a new value. When this magnetic field changes to a new value, this ammeter finds a current suddenly because the magnetic field is suddenly changing, and then it stops changing. This is just a DC circuit, because the DC circuit, it very quickly goes from no current when before you close the switch to a constant current that stops changing with time. So there's no change with time shortly after you close the switch, and so the ammeter only sees a changing magnetic field for a short time. So there's only an induced EMF in this coil for a short time and only a non-zero current for a short time. Any questions about that? The key here is that the induced EMF depends on the magnetic flux changing with time.
So at the first instant, there's still that the current from the voltage, and then there's an induced EMF to fight it.
At the instant you close this, the magnetic field inside this coil goes from 0 to some new value. B in the primary coil, the coil on the left, as a function of time, is 0 till you close the switch, and it jumps up, so there's a big change with time, and then it's constant again. So this coil on the right sees no changing magnetic field, so there's no current, no induced EMF in that coil, and no current in the circuit. Then it suddenly sees a big change with time, so there's suddenly a big change with time when you close the switch, and when it sees that big change with time, suddenly there's a big current, and then the magnetic field stops changing with time, and so that EMF goes back down to 0. So the ammeter reading goes like the derivative of the magnetic field, derivative with respect to time. And so it's 0 when it's not changing, and when it's not changing here, it's 0. And when it is changing in a big way, the ammeter goes up and it comes back down again while the magnetic field is changing.
So those coils around the iron doesn't act as an inductor?
What the iron does is it makes sure that the magnetic flux, the magnetic field through this coil is exactly the same magnitude or almost exactly as the magnetic field through that coil. If there was no iron there, this would still go upward, but the magnetic field over here wouldn't be as big as it is in the coil there because you're farther away. And if there were no iron there, the magnetic field through this coil wouldn't be as big. So the change in magnetic field, or the current in the ammeter would be smaller if you didn't have that chunk of iron there.
What I mean is the coils around the iron did not fight the change in current that was causing you to switch. So it doesn't act as an inductor.
You mean this coil?
Yes.
This coil does act as an inductor.
So shouldn't there be a bigger change in like a longer change in magnetic flux?
You're right. So depends on L and R. I mean, at some point it'll stop changing. So that should probably look something like this. There'll be a blip that is for a short amount of time, I guess. You're right. This will act as an inductor. It depends on how big, depends on how many coils. It depends on a lot of things. It depends on the inductance, in fact, what the time dependence will be. Sorry, I was completely ignoring that. But there will be a time dependence to the rise in the current. It's usually small, but anyway, it's definitely there. Any other questions?